Hello everyone, we are going to be looking at 3.2, which is the I can apply the principles of permutations and that of factorials to calculate the number of options. So our permutations and our factorials are actually quite closely related to each other. So permutations relate to a order that we would like to, order different objects, whereas factorials include all the possible outcomes of any particular event. So the easiest way, to explain these two concepts is by using an example. So I'm going to be going through the example that we have here in our notes. So, for instance, if we think about wanting to seat 5 different people in order, we would say that these 5 different people can obviously only appear one time in each seat. We cannot have a same person seated in the same seat more than one time. So, yes, there is a particular order that they must be seated in. So if we did imagine these 5 different chairs, in the first chair we can say, well, we haven't seated any of those 5 people yet, so there are 5 different people we can sit in our first chair. In the second chair, because it's one person already seated, there are 4 different people left. And then, of course, in the third chair, because I've seated 2 people already, there are 3 people left, and so on and so forth. So you can see we'd have 5 potential options, 4, 3, 2, and then 1. So to actually calculate those number of possibilities, or the number of permutations of seating these 5 people into the 5 chairs, is what we call 5 factorial. So this is 5 times 4 times 3 times 2 times 1. That is 5 factorial. So that is our possible events, the number of possible factorials or events and outcomes that we can have of this particular scenario. So altogether, it is 120. So the permutations of 5 people sitting in 5 different chairs, is 120. So 5 factorial. And it is represented by this here. So this exclamation mark here is in fact the notation or the symbol that we use for factorials. However, of course, we're not always going to have the really nice option of having 5 different people in 5 chairs. It'd be nice and fair if that was to happen. But for instance, maybe say we were on a bus and of course there are potentially 5 different people, but maybe there are only 3 available seats instead of the full 5. And that could be because all the other seats in the bus are already taken. And maybe these are like the 3 elderly chairs that are, always put aside for those who need it. So if we did have these 5 people here in these 3 chairs, we can still kind of think about and do the exact same thing as before. So instead now we've got 3 seats instead. So it's always best to think about these questions more logically, even though there is a formula that you can use as well. So in the first chair, there's still the 5 people, so I can fit 5 different people in my first chair, of course. Now, because one person is already seated, I've only got 4 people left that could possibly be in that second chair. And then finally, in my third chair, because I've already seated 2 people, there are now 3 people left that could possibly sit in that last chair. So the number of outcomes of this is 5 times 4 times 3, which gives me 60. However, my factorial kind of requires me to have the 5 times 4 times 3 times 2 times 1. So what we can do when thinking about our scenario here is we can still relate this to our factorials. It might just look a little bit different because it didn't complete the 2 times 1 part. And instead, we think about our scenario a little bit like this, where we've got the 5 times 4 times 3, like we had for the 3 people in the 3 chairs that could actually sit down. And the other 2, so my 2 times 1, it's still there. However, we've kind of divided it by kind of like the 2 that couldn't be seated. So the 2 that couldn't quite make it down there just yet. And this is, as you can see here, if we look at the bottom part of this equation, this 2 times 1, it still kind of follows the same rule for our factorials, where we've got the 5 times 4 times 3 times 2 times 1. This one now, because it's 2 factorial, it's 2 times 1. So this bottom bit here then is my 2 factorial. But if we wanted to relate it a little bit more correctly to our permutation formula here, then it's 5 take away 3 because we only had 3 options. So there were 2, I guess, kind of left over that we couldn't quite seat. So in general, the formula for this is my P N R equal to also this notation you might see a few times. And really the formula is just my n factorial over n take r factorial. So this is really, for this particular scenario, this reads as the number of permutations of n people in R seeds. So of course, remember we use this formula when order is important. Okay, so the other thing that we need to consider when we're talking about factorials is a special type of factorial. And this one's like called the zero factorial, and I kind of think it's similar to our a to the power of 0 where we did our index laws and we had anything to the power of 0 which is 1 essentially. And with this, we also kind of have the same kind of thing where we have 0 factorial is equal to 1. And I had to think, well, this kind of makes sense, right? Because if we were to look at our other factorials up here that we were looking at beforehand, if I had 5 times 4 times 3 times 2 times 1 times 0, anything multiplied by 0 would just be 0. So it just wouldn't exist. And there would be no point of us doing these factorials here. So, I mean, I guess you could kind of say that this would be 5 times 4 times 3 times 2 times 1 times 1 times 1 if you wanted to include the 0 part. But really, to make it so that our factorials kind of don't break, we just say that for all 0 factorials, it's just equal to 1. And of course, down here, a little bit further on, you can see that we've also got our calculator instructions, but I will not go through this. I'm sure you can have a look and see how to do this yourself.
Our first example here has a license plate that begins with 3 letters, and the possible letters that can be chosen are A, B, C, D, and E. And it's asking about how many different permutations of these letters can be used if no letter is to be used more than once. So some key bits of information here are the fact that we are using 3 letters and that we have a possible combination of 5 different letters here. As well as the fact that no letter is to be used more than once. And of course, this question has said that we are using permutations, so this is where order does matter. In this case, we have been given our permutation formula, of course. We know that we've got our P and R is equal to my n factorial over n take away r factorial. However, although we can use our permutation formula, and I will encourage you to use it, the other thing we can do is just really think about this logically. So in this case here, for my number plate, I know that I have 3 letters to use, and I know that there is a potential of 5 different letters. So in this case here, in my first spot, if I was managing my license plate, at this stage, I can put 5 different letters in this first spot here without repeating any of them. In the second part, I'd only have 4 different letters left if I wasn't to repeat them. And then finally, in my last spot, I would have 3 left over here. So the number of permutations would just be 5 times 4 times 3, which would give me 60. Now, if I was to show this using the permutations formula, I know that my R here, I've kind of got in my pink, and the N, the number of different choices that I kind of have, is my 5 different letters here. So actually plugging this into the formula and using it, I'd have P of 5, 3, and this would be 5 factorial over 5 take away 3 factorial. This would be equal to, of course, 5 times 4 times 3 times 2 times 1, all over. 5 take 3 is 2, so that's 2 factorial, so I've just got 2 times by 1. And I can see here that this 2 and 1 is going to cancel out. And of course, this is just going to leave me with 5 times 4 times 3, which, as you can see, is exactly the same as what I have here, just thinking through this question logically. So of course then I know that my final answer should be 60. So there are 60 different permutations for this question here. Okay, so if you can, I do encourage you to think about it logically, but then of course show your proper working out using our permutations formula that you've been given. This last question here, of course, I have literally been given it to me in terms of the formula of my, I should say my notation, my permutation notation. And I'm just going to use this exact same formula here to solve this one. So this is P, and then I've got 3, 2, and this is going to be equal to 3 factorial over n take r, so 3 take away 2 factorial. So I've got 3 times 2 times 1, all on the top of, so 3 take 2 just gives me 1 factorial. And of course, looking here, I can see that my 2 1s cancel out, though they won't really do that much, really. And I'm just going to have 3 times by 2, which is just going to be giving me 6 permutations here. And that is all that we have for this example.